Welcome back, students. This is the session 9 from the playlist of friction, and this is the Q&A session. And for this session, I have taken this question which is written on this board. Questions which are very similar to the one which I have written on this board are asked in the IIT-JEE examinations. You will find questions which are very similar to the one which I have written here, which were asked in the previous this IIT-JEE examination. So if you are able to understand the concept behind the solution of this problem, then it will be very easy to even solve the complex problems pertaining to these type of questions. So in this question, a horizontal force of 10 Newton is holding a block against a stationary wall. So I am just drawing here. This is a station. This is a wall, and a horizontal force of 10 Newton is holding a block against a stationary wall. Against a stationary wall. So this is a wall. This is a wall, and let us say this is a block. So our horizontal force means this is the wall, so the horizontal force will be like this. A horizontal force of 10 Newton is holding a block against a stationary wall. So this is the stationary wall, this is the block, and a horizontal force of 10 Newton is applied on this block so that the block is held stationary. The coefficient of friction between the block and the wall is 0.2. That is the coefficient of friction. Let us say it is mu. This is equal to 0.2. The coefficient of friction between the between the block and the wall is 0.2. So in this case, we have to find the weight of the ball. If this block is held stationary by the horizontal force of 10 Newton. Now, since this is a wall and this is a block, and this block is held stationary by the application of this horizontal force, so now we can solve this question by the method which I will be just explaining it to you. Now, the weight of this block will be acting downward. Let us say the weight is equal to m into g, and this block will be held stationary by the frictional force. Now the frictional force will be acting in the upward direction. This block will be held stationary by the frictional force which will be acting in the upward direction. And this frictional force, if I am just denoting this frictional force by let us say Fs. So this Fs is equal to mu into n, where n is what? N is the normal reaction. N is the normal reaction. Now, in this case, we are applying a horizontal force on this block, and this block is resting against this stationary wall. So this wall will exert a normal reaction in this direction. This wall will exert a normal reaction on this block in this direction, and the magnitude of this normal reaction will be equal to 10 Newton. So the force of friction, that is Fs, will be equal to 0.2 into the normal reaction, and the normal reaction will be equal to 10 Newton, because we are applying a horizontal force on this block which is held stationary against this wall, and if the block is held stationary against this wall, then the wall will also exert a normal reaction on this block in the direction indicated by this arrow. So So the normal reaction is equal to 10 Newton. The force of friction is equal to mu into N. So this is equal to 0.2 into 10, which is equal to 2 Newtons. Now since the block is held stationary, it means that the force of friction is balancing the weight of the block. Okay? So from here I will be just writing that the force of friction, that is Fs, is equal to 2 Newton. Since the block is held stationary, against the wall, therefore it means that the force of friction, or the frictional force, is equal to the weight of the block. If the block is held stationary against this wall by the application of this horizontal force, therefore it means that this frictional force which is acting in this upward direction is balancing the weight of the block, or we can say that the frictional force is equal to the weight of the block. So since the frictional force is equal to 2 Newton, therefore we can say that the weight of the block is equal to 2 Newton. Okay, so the correct option is D. So in this case, the most important thing which you have to remember is that when we are applying a horizontal force here on this block and the block is held stationary, then in that case the wall will be exerting a normal reaction in the opposite direction of this applied force, and this this normal reaction, that is N, is equal to this normal reaction, which will be equal to 10 Newton. That is, the magnitude of this reaction will be equal to the applied horizontal force. So so in this case the normal reaction becomes equal to 10 Newton. And now since the force of friction is equal to mu into N, mu is given as 0.2 and N is equal to 10 Newton, so the force of friction is equal to 2 Newton. And since the block is held stationary by the application of this horizontal force, therefore we can say that this frictional force is balancing the weight of the block, or the friction force is equal to the weight of the block, or in other words the weight of the block is equal to 2 Newton. So thank you very much for joining the session, and in the next session I will be coming up with some different types of question on the from the same topic, that is friction. So till then, have a nice day. Bye.